We're asked to find the terminal point on the unit circle determined by 3 pi over 4 radians. Quite a few different ways that we could approach this and look at it. So if this way doesn't work, there's other things we could try. But the big thing that they're looking for, whoa, I don't know why that's so big. The big thing they're looking for is that 3 pi over 4 radians. You could think of that as a degree. It's an angle measurement. Let's see. So 3 pi over 4. I'll show you why it lands over here in just a second. And yeah, and I guess a little primer here. When you draw an angle on the x and y coordinate system, we always call this the initial side. Okay, that's where the angles start being drawn. 0 degrees is this line right here. So like 30 degrees, that would be this line right here, et cetera, et cetera. Okay, so if you've got 3 pi over 4, I'll explain why that's somewhere over here in the second quadrant in just a second. So we draw a line from the origin to where that line should terminate. I guess we should just do it now, right? 3 pi over 4, if you're not familiar with radians, radians are like the angle in a circle that has a radius of 1. So if you think back to the circumference of a circle, the circumference is 2 pi r. Well, if r is 1, then the whole circumference of a circle is just 2 pi, right? The whole way around the circle is 2 pi. So if you go like 1 pi, that's halfway. That would be right here, halfway around the circle. So I knew 3/4 pi was somewhere less than 1 pi. That's why I drew it there. But here's another reason why we know 3/4 pi has to go there. You can convert it to degrees. If you haven't practiced that very much, the quick trick is to convert from radians to degrees, cut the pi out, then multiply by 180. And if you do that with a calculator, 3 times 180 divided by 4, that's 135 degrees. Okay, so this angle here is 135 degrees. Excuse me. So to find the coordinates here, they want to know what are the x and y coordinates for this dot. If it's on the unit circle, then we know this right here that I'm going to draw in red is 1 because the unit circle, like I said, has a radius of 1. So that's great, but that's not an x and y coordinate, so we still need to do some work. What we need to find, I can color code this, is the x coordinate, which is this distance here, right? And we also need to know the y coordinate, which is this distance from the point right here. We need those two things. So to find them, we can use trigonometry. Okay. It's tough to think about like what students have or haven't done at this point, because now what we want to do to figure out what the blue line is and what that teal line is. Is that teal? The kind of greenish blue thing. To find out what those are, we need to use sine or cosine or tangent. Okay, and so look, when I drew those distances, I drew a triangle, right? If this is 135 degrees here, then we have 45 more degrees to complete the full semicircle there. So this would be 45, right? Because 45 plus 35 makes 180. So I know inside this triangle's got to be 45. And now I can start doing some right-angled trig, okay? Because sine is the opposite, which is what we want. What color did I use? Seafoam. If we look at the ratio of sine, sine is sine of some angle is the opposite divided by the hypotenuse of the triangle. Okay, so what's opposite of 45 is x. The hypotenuse of the triangle is 1. We label that in red. So that should equal sine of theta, which is theta in this case is 45. So now we got a little equation we could solve for sine, right? Sine is, let's see, it's square root of 2 over 2. Use exact values. Okay, so sine of 45 is square root of 2 over 2, and you can check that with a calculator. 45 degrees, hit sine. And so that's 0.707, but they asked us to use exact values, not decimals. If you take 2, square root it, divide by 2, that's 0.707. And the way I got that was kind of through memorization, okay? Like, it's unfortunate, but there's just some triangles, there's some measurements we just have to know. And you can look this up online. You could look for the unit circle values for sine, cosine, and tangent, and they'll have them both in degrees and radians. But the way it works is you can memorize triangles. If it has 45-degree angle here, and if it's a right triangle, then this has to be 45, and it's always going to be square root of 2 over 2 for these side lengths. Okay, and then another triangle you can memorize is square root of 3 over 2 corresponds with 60 degrees, and then this 30-degree angle up here, that has to correspond with 1/2 down here. Okay, but again, you could look up these values to find out their exact values, but sine of 45 degrees, when you look it up, you should see that it's square root of 2 over 2. Okay, so we just found out at least one of these values. The y value is square root of 2 over 2. Okay, so to find the x value, let's set up another trig ratio. It's going to be the same type of thing, okay? We want to know that blue line that I just drew. So we want to know the adjacent, right? If this is 45 degrees, and if the teal is the opposite, the red is the hypotenuse, then that unknown there, I should have used y, sorry, that last one. That might have been a little confusing because that was a y coordinate. But that blue is the adjacent. That's the thing that we don't know. So that's what we want to solve for. And we don't want to try to, we could use the opposite, adjacent over opposite, that'd be cotangent, but it's easier to think of this as the adjacent over hypotenuse equals cosine of 45, right? Because the hypotenuse is a nice and easy 1. So if you plug this in if you look this up online for the exact value, well, x divided by 1 is just x, right? And if you look up cosine 45 online, it's square root of 2 over 2. But before I put that in here for the blue line, I'm going to make it negative because think about where we are on the x-axis. This is positive 1. This would be positive 2. So this should be negative 1. We're on the negative side of the x-axis, so that's why I had to make sure that was a negative square root of 2 over 2. So unfortunately, there's a lot of like different little pieces that have to come together. So it really depends on where a person is and like their trig work so far. Oh, come on. Negative square root of 2 over 2. And then this one we said was a positive square root of 2. I don't know why it's so hard to do that, Alex. Gotta highlight it? What are you gonna do? Come on, give me a fraction. Excuse me. Oh. Looks like the hardest part for me is typing it in. There's my square root of 2 over 2. Okay, let me do another one. Okay, terminal point in the unit circle, negative 5 pi over 6. You can convert that to degrees using that quick trick I showed you. Cut the pi out, multiply by 180. So if we do 5 times 180, divide by 6, keeping in mind it's negative, this is negative 150 degrees. So negative 150 degrees just means from that initial side, you just rotate clockwise. You go the opposite direction. Here's negative 90. So negative 150 is somewhere here because it's not quite negative 180. So there's our side length. We need to know these x and y coordinates. So to find that, if this is negative 150 degrees, then we have 30 degrees left here. And so now that we know how many degrees we have left, we need to find this y coordinate, right? And we need to find this x coordinate going across. Okay, got to find those two things. So again, they said it's in a unit circle. So that's great because we know that this has to be 1. That's the property of the unit circle, is that it has a radius of 1. Now we can use those sine and cosine ratios to help us. Okay, so if we're trying to solve for, I'll use the right letter this time. We're trying to solve for y here. Y is opposite over 30 degrees, and we want to use the hypotenuse because that's known. That's 1. So the opposite divided by the hypotenuse, that's a sine ratio. And then again, these values or values that we just end up memorizing. From the past, I know that sine of 30 with that triangle I just drew, actually. I drew that 30 corresponds with 1/2. So I'm going to say y is 1/2, but before I put down my final answer, I'm going to make it negative because I'm noting that it's going down on the y-axis. Okay, so there's the first one. Now to find the red one, that's adjacent to 30. Okay, it's not the opposite, it's not the hypotenuse, that's adjacent to 30. So I'm doing an adjacent divided by hypotenuse, which is 1. So that's a cosine ratio. Oh, sorry, 1 second. I need a little extra detail here. Yeah, on this next one, I was about to jump to the wrong conclusion. Okay, so with cosine of 30, again, this is a value you could look up. But if this is 30 degrees, we said in those special triangles, 1/2 corresponds over here. Now that doesn't tell us what cosine is, though, right? Because cosine, it deals with the adjacent side. So when you fill out that triangle for 30 degrees, looking from 30 degrees perspective, cosine would be square root of 3 over 2. So x equals, and then again, you don't necessarily have to do that triangle way. You could look up that table of values. Cosine of 30, the exact value is square root of 3 over 2. And then again, just check the sign. It should be negative because you're going backwards on the x-axis. All right, let's see how bad I can mess this up. I'm going to try to type it in. There we go. Negative. Got to tap it twice, I guess. Negative square root of 3 over 2. And then this one we said is a nice easy negative 1/2.